Just don't get a 0 on your final, you'll be all right. And don't forget to do your portfolio. All righty. And we're live. Welcome. Leave Tucker alone, okay? Eads. Jealousy is not a good look on you. All right. Here we go, babies. Let's do it. Find the length of AB. Here's my logic. If you're not paying attention because you don't have finals, please be quiet so we can hear. Tucker? Doesn't hear me. Tucker and Eads. I know you guys don't have finals, and congrats to you, but make sure you're quiet enough so other people can hear. I know you don't have finals, but other people do. So make sure you're quiet enough so they can hear me, okay? Rad. Here we go. So I want to find the length of AB. That's this guy right here. So the way I'm going to do it is I'm going to say that this segment minus this segment gets me this guy. So I'm going to do x plus 16 minus 6, and that's going to get me AB. Come on. When I do math, I get x plus 10 equals AB. So that's x plus 10. Now we are not done, because I want to know what AB is, not what it is if I know what x is, right? I want to know a number for AB. So next thing I'm going to do is I'm going to take this segment and subtract 6 from it, and that's going to get me this guy. It's going to get me CD. Doing purple. So the blue segment, negative x plus 1, minus the green segment. Gentlemen, Eads in particular, your voice carries. Better not happen anymore. Negative x plus 1 minus 6 is negative x minus 5. So I'm going to write that in. That's what CD is, negative x minus 5. Cool? Now that I've got that, I can say these 3 segments add up to the big one on the bottom. The big one. So pink, green, and purple are all going to add up to the orange. So I'm going to write that. Pink is x plus 10. Green is 6. And then I'm going to wrap this one in parentheses because it starts with a negative. Negative x minus 5. And that all equals the orange, 3x minus 4. So now I'm going to do math. X minus x, the x goes away. And then I've got 10 plus 6, which is 16. Minus 5 is 11. So the x goes away. We're left with 11 on this side, and 3x minus 4 on the other. And I'm going to add 4 and divide by 3. So x is 5, but we're not done. They wanted us to find the length of AB. And we know that AB is x plus 10. So how long is AB going to be if x is 5? 15. So I'm going to write that down. Yep, it's uploaded right now. It's going live. And while I haven't done, this is only basic geometry review I have. Later tonight, I'm going to do the review from 6 to 9. That'll be uploaded. And then the other geometry reviews, a lot of this is similar. They have to do an entire proof for this, so they have to back up their reasoning. But it's very similar. Okay. If you have questions now, ask them now. We're not going to get through this whole thing anyway. We might as well take our time. I don't want to talk to you right now because you don't need to review. Anybody else have any questions? No? Okay. Yes, you may. That's the idea there. I gave you some more examples to try. It's the same idea. Okay? Make sure you read the directions and figure out what they're asking for, right? They don't want X, they want what AB is. That's the common mistake, is to get X and then stop. take a look at this guy. We're on page 4 of your hymnals, question 4. So we're trying to find the distance between these 2 points. And we're going to use Pfag to do it, right? That's the idea. So where does distance formula come from is what we're talking about. Well, it comes from Pythagorean theorem. To find the distance between those 2 points, the distance is a horizontal length, right? And that's kind of hard to calculate. You just can't count it. So what we're going to do is break it down into parts that we can count, right? So here's the idea. Draw yourself a coordinate plane like this, and we're going to label our coordinates accordingly. This guy's coordinate, well, it's going to be some x value and some y value, right? So I'm going to call it x1 and y1, since it's the first x and the first y. So that guy's coordinate is x1, comma y1. I'll zoom in. Better? This guy's coordinate, second x, because it's on the x-axis, comma y1. So that's x2, y1. I think next year I'm going to make it no one gets exempt from my final. Too much happiness in here right now. Doc, if you get any trouble about that, Ava, same for you. If you get any trouble about that signature, send them to me, okay? This one here is going to be x1, y2. Does everybody see where I'm getting those at? x1, y2. Is that coordinate? Feeling good? Okay. Shout out to Maddie if she's watching this at home. She might be later at some point, potentially, maybe. I hope. But if not, just get better, yeah. So that's the coordinates. That's step 1. So how long is B? Well, if that was 10 and that was 2, how much space do we have here? It'd be 8, right? 10 and 2, right? The space between them is 8. Space between them, right? So what we really did was we subtracted those guys. Remember, subtraction is distance. B is the horizontal distance. A, on the other hand, would be the distance between here and here, which is just the distance between these guys, which is y2 minus y1. Again, if that was 10 and that was 7, they'd have a distance of 3 between them. Cool. So I'm going to write that. B is whatever x2 minus x1 is. And A is whatever y2 minus y1 is. Let's talk about what those mean. Subtraction is distance, so this guy is talking about horizontal distance. That's what B is, right? And that's vertical distance. Go. Last thing is we're going to take that and plug it into Pfag. Right? So what is Pythagorean theorem? If you want, guys, you can just have your phones ready and take pictures instead of trying to copy all this down. It'll be in color that way, and you can pay more attention to what's going on. I would highly encourage that. If you want to copy stuff down later, I have extra review packets that you can look at that have this filled out already. They're not basic geometry, but by the time we get through this, it will be, right? So Pfag is a squared plus b squared equals c squared. So now I'm going to plug that in. We know A is this, so I'm going to take that and plug it in for A, and I know B is that, so I'm going to take it and plug it in. So whatever A is squared plus whatever B is squared equals c squared. Well, A we said is y2 minus y1. And B is x2 minus x1. And then I root it to get C on its own. So I'm going to write that again, but rooted. And that's my little proof of the Pythagorean, or the distance formula. That's where it comes from. Horizontal distance and vertical distance put together. It's going to be the length of the diagonal put together through Pythag. What you think? Label your coordinates, right? Get your lengths. Subtraction is distance, right? And then plug them in. Okay. Awesome. I like your boots. I like your outfit. Well done as usual. Where do you get a dress like that? I know. Rad. Questions on this one? Okie dokie. Turning the page. Two things I want you to do here. Find the distance and find the midpoint. How do I know midpoint? Because it's a 1-to-1 ratio. That means here's point A, here's point B, and we want to cut that up into a 1-to-1 ratio. Well, 1-to-1 means we have one piece on one side and one piece on the other. So we're cutting it in half, right? That's what that means. So that's going to be our midpoint. That's what 1-to-1 ratio means. 1 and 1. How many pieces total do we have? 2, right? So midpoint is average of your x's, average of your y's. When we average stuff, we add them and then divide by the number of pieces. 2 pieces. Whoops. 1 each, right? Okay. We're going to plug in our numbers. Notice that x2 and y2 come first. That's not important for this problem because it doesn't matter where we start. If we start on A and walk halfway and start on B and walk halfway, we end up in the same spot, right? But if we only wanted A walking a quarter of the way, right, B would have to walk further. So where you start matters. Here it doesn't as much, but just so you get in the habit of it, x2 and y2 come first, okay? On the next problem, it will matter. So x1 and y1 are going to come from A, and x2 and y2 are going to come from B. Because B is the destination, right? We're walking towards B starting on A. So when I plug those in, x2 goes first. So that's 1. x1 goes next. That's 5. Then y2, -7. And then y1, 3. 1 and 5 makes 6, and when I divide that by 2, I get 3. -7 and 3 makes -4, and I divide that by 2, I get -2. So that's our midpoint. And if you graph A and B, A is at 5, 3, 1, 2, 3, 4, 5, up 3. There's A. And you graph B, 1, -7, 1, 2, 3, 4, 5, 6, 7. If you draw your line well, which I really didn't, you'll find the midpoint is right in the middle. Right there. 3, -2. Okay? Now we want to find the distance. Well, isn't distance the same thing as Pythagorean theorem? Well, when you have a drawing in front of you, make it into a right triangle. And do Pythag, right? That'll be how long the pink the purple line is. So I can count that. That's 4 across. That's the horizontal distance. And the vertical distance is 10 if you count it. So I'm going to do Pythag with those. 4 and 10. I'm going to square them, add them, and root them. And that's going to get me the distance. Well, that's 16 plus 100. And that means that's 116 rooted, which doesn't come out nicely. But that's the distance. If you use distance formula, you'd plug in your coordinates. And it would tell you that when you subtract your x's, you'd get 4. And when you subtract your y's, you'd get 10. So why do all that work if you can just count, right? If I don't give you a drawing, either make your own or, right, plug those coordinates into distance formula. But if you have a drawing, go for it. Questions on that one? Are you good with the ratio being 1 to 1, so it's midpoint? Okay. Number 6 has a different ratio. In fact, it gives you a fraction. Because that's how most people talk, right? They don't say, I want to meet you 1 to 3 parts of the way, right? They say, like, I want to meet 1/4 of the way. Right? I'll drive 1/4, you drive 3/4, right? So they say, I want to meet you 3/8 of the way. Just a little under half, right? So we're starting on A. And we're going to B. So that's x1, y1, and that's x2, y2, because we're going towards B. So 3/8 of the way. Here's A, here's B. If I want to go 3/8 of the way, what's up, Rylan? 3/8 of the way is going to be 3 out of 8, with 5 left over here. So 3/8 of the way is 3 to 5 ratio. Make sense where I got those numbers? 3/8 of the way is 3 out of 8 total pieces. So there's 3 pieces on this side and 5 pieces on that side. 3/5. 3 to 5. Question? Nope. Okay. How do we feel about how I got that? Because those are the numbers we're going to need to use for our formula. You smile about Corinne. Good. Too much happiness in here. Next time, no one's exempt. Make sure you all fail before the final. So, we're not going to call it midpoint anymore, because it's not the middle point. We're just going to call it P. Some point, right? That's 3/8 of the way. We're still going to average our x's and average our y's, except there's going to be a total of 8 pieces now. And there's going to be 3 pieces of x1, or I'm sorry, x2. And there's going to be 5 pieces of x1. That's why x2 has to come first. So it gets the 3. 3 to 5 ratio. And over here for our y's, it's going to be 3 y2s and 5 y1s. Feeling good? Okay, 8 total pieces, right? We add them up and divide by the number of pieces, 8 total. 3 and 5 makes 8. When we plug stuff in, here's what we get. What comes first, x2 or x1? x2. Don't goof that up. You're going to find the point that's 3/8 of the way from B, right? x1 comes next. Then we have y2. And then y1. Now we're going to do math. 3 is what we get there. Negative 35 here. So negative 32 over 8. Negative 18 plus 10, negative 8. So P is going to be negative 4, negative 1, because that's what they divide to. So if we graph our original points, A is negative 7, 1, 2, 3, 4, 5, 6, 7, and up 2. That's A. And B is 1, negative 6. 1, 2, 3, 4, 5, 6. A lot of distance there, and if you draw your line well, which I did not, then P should be 3/8 of the way, a little less than half. 1, 2, 3, 4, down 1. See, I didn't draw it very well. That's a little less than half, starting at A, going towards B. If you'd started at B and gone towards A, you would have got this point. So if you screwed up your x2 and x1 and flipped them, you would have gotten this point. How do you feel about this? It's a lot of stuff going on there, but if you know what you're doing, it's not that bad. If you don't know what you're doing, meet with me, and I guarantee I can teach you it. But if you already learned it before, you're just reviewing it, right? Feel good. Find the distance, draw your triangle, right? We'll leave it at that. 7 and 8 are the same thing. That's going to be a 1-to-1 ratio, so midpoint, right? Look at 8. Our ratio isn't given to us, it's given to us as a fraction. So what's our ratio going to be? 2/7 is going to be what? 2 what? Not 9. Divide it up into 7 total pieces. This guy gets 2. How many does this guy get? 2 to 5 ratio. So it's going to be 2x2 plus 5x1s over 7 total pieces. Same thing for our y's. Remember, y2 and x2 come first. That'll be our formula, right? Tucker, you drop them and be upset. I think I believe in gravity more than I believe in you, but continue. It's not all geometry is flatland geometry. Some of it's curved, like the Earth actually is, right? And so when you draw a straight line on the Earth, it actually ends up being a curve, right? And if you draw a curve on the Earth, it actually ends up being a straight line. Pretty bizarre. Yep. If you draw a triangle on the Earth, because it's round like that, all the internal angles won't add up to 180. Will add up to something else. What? Really? This Maddie? Red. Yeah, it was. Mm-hmm. You had a guy that was named Adam Smith? Here? Oh, rad. Adam Smith is like one of the best economists ever. I didn't work with a guy. I replaced a guy named Adam Smith in my 2 jobs ago. Economics, yeah. This one. Well, normally midpoint works like this. You have 2 endpoints, right? And you plug those into the formula and it gives you this guy, right? We're going to use the same formula, except now we know this one and this one, but we don't know this guy, right? So instead of plugging both these guys in, we're only going to plug one of them in, because we only know one of them. I'm going to plug in the midpoint because we're already given it. Midpoint is the what? And that's right. When we average stuff, we add them together and divide by the number of pieces, which in this case will be 2, right? Because it's a 1-to-1 ratio, right? X2 comes first. Oops, sorry. X1 comes second. We're averaging our x's, averaging our y's. So x's go together, y's go together. Now in this one, we know our midpoint. It's this. It's 1, 5 halves. And we know one of our endpoints. It's -3, -2. So I'm going to plug that in for x1 and y1. But we don't know our other endpoint. That's this guy. So I'm going to leave it as x2 and y2. Right? Normally we take these 2 guys and we plug them in, and we get this one. But we only know one of them here. Don't plug the midpoint in here. A lot of you guys want to plug it in here. That's the midpoint. It goes here. Okay? Normally we're solving for it, but this one they gave it to us. So now we're going to do some math. I know this part right here should equal 1, so I'm going to write that. Instead of writing x2 plus a -3, what could I write? Instead of plus -3, what would I write? -3, right? Positive and negative stays negative. How do I solve a problem like Maria? Well, I got to get rid of division, and I got to get rid of the -3. So let's get rid of division first. What do? Multiply by 2 to both sides. When I get this, I get that. Then I'm going to add 3, and x2 is 5. So endpoint number 2 has 5 for its x-coordinate. Over here, I know that 5 halves should equal y2. Instead of writing plus a -2, what should I write? Just -2. Makes it easier. Get rid of division by multiplying by 2. What's 5 halves times 2? Because I need to multiply both sides by 2. What's that going to be? Try again. What's 2 times 5? Divide by 2. Another way you could have done it. 2 divided by 2 is? Times 5 is? 5. Don't memorize the rule if things go away and you get one of the numbers. Oh, okay. So that's 5. And then we add 2 and we get 7. So there's the other endpoint. Fun fact, and if it blows your mind, don't pay attention to it, because I need to see the work either way. But see how we started on -3 for the x, and then we traveled to the midpoint, and we went to 1? How much did we go from -3 to 1? We added how much? 4, right? Add 3 to get to 0, add 1 more to get to 1, so 4. It's okay. So we added 4 to get to here. We added 4 to get to the midpoint, right? Well, if I added 4 on one side, shouldn't I add 4 on the other because it's halfway? What's 1 plus 4? Oh. Right? -3 went to 1, so I added 4. And then to go to the other point, I added 4 more. 5. Here it's a little bit trickier because there's a fraction. There's a fraction. Oh, that was awful. We're going from -2 to 2.5. So we added 4.5. If I add 4.5 to 2.5, I get 7. Do I need to see all this work? Oh, yeah, I do. But you can check your work by the logic. We went from -3 over to +1, so we traveled 4. So we're going to travel 4 more on this side and get to 5. Here we went from -2 to 5/2, because we went up 4.5, and then we went up 4.5 again, and we got to 7. I don't know. No way to think of it. You need to see the work, though. How do we feel about the work? Setting it up, plugging in midpoint where the midpoint goes, right? Don't plug it in where it doesn't go. Plugging in one of the endpoints, leaving the other to solve. Okay. All right, now easier questions. Number 11. Name the angle. Give me a name for this angle. Aww. Angle A, we can name it by its vertex. What else can we name it? Nope, can't name it that. How about MAP? Vertex in the middle, right? What's another name? PAM, Pam. Another name, angle 5, right? Jane. Jim, good one. Name the two rays. Hi, Ray. AM is a ray. What's the other ray? AP. Direction matters, starting in A, going to P, so AP, not PA, right? Cool. Angle classification. Name the angle classifications. Give a definition, right? Acute angle. Anything between 0 and 90 that isn't 0 and isn't 90, right? Because if it was 90, it'd be a right angle. So the way I'm going to write that is that if the measure of an angle that I'm talking about is, this is how I'm going to do it, acute, then angle A is between 0 and 90. Doesn't include 90, doesn't include 0, right? No lines underneath. It's between 0 and 90. That's how I'd read that. If it is right, then the measure of angle A is what? 90, exactly. If it is obtuse, then it's between what? Yep. 90 and 180, non-inclusive, right? Can't be 180, because if it was 180, it would be a straight angle. And if it's between 180 and 360, that's a lot of territory to take up. But if it's between those, then we call it a reflex angle. That's the one where it's like hyperextension, right? There's 180. Further than that is reflex. And then we have, if it's a revolution, then it is exactly 360, right? Whoops. A revolution, right? If it's complementary, then it takes two angles, right? Then angle A must add with angle B, another angle, to equal 90. If two angles add up to 90, then they're complementary, right? What's supplementary? Yep. Don't goof them. So if we have two angles that add up to 180, then they're supplementary. Take a picture if you want. I've been getting better about saying picture instead of screenshot. You don't take a screenshot in real life. You don't. I'm very online. It's live, yep. And if you can't make the 3 to 6 session today after school, then watch that at home or later. Yeah, that's fine. Okay. I know the first review session I did yesterday from 12 to 3 online. First hour was boring. Second 2 hours of the 3-hour session were hilarious, so I would encourage you to watch that as well just for fun. I was here from noon to 9 yesterday. And I was there on Friday from after school till 6. No, Saturday I was here from 1 to 4, and I'll be here from 3 to 9 tonight, and I'll be here from 3 to 6 tomorrow. Which is why I don't have any extra grading done. I've literally been spending all my time here, and I hope I have enough gas to make it to the end of the week. Paycheck's Friday. This one, a Venmo. Mr. Bartos has a Venmo? Is that what you just said?
No, I said you should set up a bed.
Oh, a bed. Bartos does not do that. Cross off that. I probably will have to. I'll Uber and one of you guys will pop up. I'll be like, oh, great. Change this to 130. I'm sorry, I rewrote the problem and forgot to change those little bits. So this is what they're talking about. That's CAF, right? And this is 130 in total. So here's what we're going to do. First things first, I know these three angles should add up to 95, so I'm going to write that. This angle plus this angle plus this angle should all add up to 95. That's angle addition postulate, right? Okay. Then I solve for x by doing math. That's 75 put together. And that's 2x. And then I subtract 75 and I get 20. And x is 10. Now that I found x, they want us to prove that BAF is 130. So I'm just going to plug it back in, right? So we get 4x plus 35 plus 2x. What's up? Plus 40. Shut up. Equals blank. We're going to plug in 10. So that's 10. Eads. Get back in here. So we have 40 plus 35 plus 20 plus 40. 40 and 40 makes 80. 20 makes 100. 135. Oh, yeah. That's 135, not 130. My bad. My bad. We made it to page 11. No, 45 for them. They have fewer proofs. Thank you.
I was in Chicago over the weekend, and
What you got?
my man was just vibing. Wait, ready?
Do I know these people?
No, he was just vibing. Look at him.
He was.
Vibing. Yeah. He was doing that one Squidward dance too.
It's amazing something to say.
It was really good.
Brian, what's it say?
I don't know.
Okay, I might know him.
I know him. Look, my sister's my sister's really good. Like,
Yikes.
she did that. I was like, that's makeup. That's makeup. Yeah.
Okay, good.
My sister. I thought it was real. No, I was.
Well, if she gets the yikes reaction, then that means she did a good job.